Welcome to the second in a series of screencasts covering the basics of Rhino Grasshopper. So, starting where we left off, let me go ahead and delete the sphere and the cone, and we'll go ahead and leave the rest of these elements aside for now. And the surface, I'm going to go ahead and name it, right click, and again we can go up top and name it whatever we want. So I'm going to say surface. I guess something a little more visible. And we're going to do is go into the second tab, the Math tab. So we started in the Parameters tab. We're going to move to the Math tab. And you can go ahead and go through these panels and see different options you have. The scripting is very useful if you can get into it. There's C# and VB and Python 2, which I encourage. So you have trig functions, of course, all sorts of mathematic utilities. So anyway, what we're going to focus on real quick is domain, specifically the divide domain. And it's a way to quickly give a surface or a B-rep segmentations or a grid. So let's go ahead and use our scrubber. And just to show you real quick, I'm going to change the max value just so we don't blow this thing up. And plug it in for the V for now, and plug in my cool surface. And now we're getting an actual response. We have 400 individual segments. And if we go to this surface and go to Utility Isotrim, we can visualize these. And we're going to take these surfaces as the domain here. Now if you look over in Rhino, you'll see the subsurfaces that we just created. And you'll see as we scrub this, the amount of surfaces, the grid itself changes dynamically. And so there's our parametrics in action. And we can go ahead and make two of them, give them their names, some autonomy, and show you this real quick. When you select things, you'll notice these little elements here. Well, this will align things to the left, align things to the right, center them, and be careful though, because this will align to the right too, and it will stack them like so. So you can lose your elements really quickly. So just drag the V to V, leave the U to U, and you'll notice now each one is independent, and you can dial it in however you would like. Again, remember this is in Grasshopper, so this is only referencing the surface in Rhino. This isn't deforming or anything. So if we went back into Rhino and selected our surface, I'm going to rebuild it so that we give it some variability in the UV, as it's when it's built there's just one. So we'll do a rebuild, and this is good. We'll do 12 by 12. So now that gives me the ability to turn the points on, and I have my point grid from which to edit. Go ahead and select a random set of points. A few more. And now we can turn off our points. You'll see we have a more complex surface there. And we can even click on it and leave the curve. Click on the surface in Rhino and hide it. And so now this is our Grasshopper solution. And as you click on the pieces in Grasshopper, you can see that they reference as green and Rhino. You can also right-click any component that you have in Grasshopper, and you see the preview. If you click on it, that preview is then gone. So if we come to subsurface, right-click, there's nothing to preview anymore. Everything's a dark gray. It can only be previewed, or it's only visible rather, when it's a light gray. And so that's when the output itself is actually visible in the Rhino window. And so a lot of times what you can do is, as you build, it'll get a little difficult to see your individual component references in Rhino. So you can group and go ahead and turn visibility of elements off as you're migrating through your, or progressing through your definition. So for now, we're going to get our subsurfaces, and we're going to move into the next tab from math to sets. And in sets, you'll notice the panels of list, sequence. These two in particular can be really helpful. Sets, strings, and then this last one is a really invaluable tool for a complex organization and referencing. And we'll get into this a little bit further down the road, but to start off, we're going to do list. And specifically, we're going to look at the list item. And what the item does, the list item lets you find an individual item object within a list of objects. So you'll see the subsurface. If we were to bring these subsurfaces to list item, you'll notice that it's the very first item in the list. And what we can just as easily do, then come grab a scrubber, hit it onto the eye, and now you'll notice that we can change which one we're looking at on the fly. You might say, well, what do I do with that? Well, what this can do is then allow you to reference things not just as individual items, but as groups of items. So if we go to the surface and we look at the analysis, you'll notice there's VREP components, and this is a little icon for exploding a VREP. So we explode our subsurface into its components, and that means its faces, its edges, and its vertices, which is the points that make up its outline. So go ahead and turn off the subsurface. And so now what you're seeing is each one of those subsurfaces exploded into its individual components. And if we, so for instance, there's a single face, there's 4 edges, and there's 4 vertices for each panel. And so what we're going to do is use the list item to reference each individual vertices, or a series of edges. So we're going to start with the vertices. So this item, and there's 4 of them. So I'm going to copy and paste this 4 times, or 3 times rather. Grab it. Keep the same group of vertices as the list. And then for the item, we're going to use a panel, a series of panels. Start at 0. And 0 is 1, so you already started with base 0. So we're going to do 0, 1, 2, 3. Now we can plug those into those items. So if we turn off the exploded elements, you'll see what we have here is the points, or vertices, of our geometry. And so back in Rhino, if I do a show, come back, reference our geometry again, turn the points on, you'll notice the changes take effect, and the Grasshopper references happen on the fly. So now we can use these vertices to create other geometries, or we can also use the other pieces, the faces and the edges, to extract other elements from our subsurfaces. So what I'm going to do is copy 2 items, and this time we're going to send the edges as the list. And now you can see our lines that we have, and they follow our UV curve. We can always go right back down here to our UVs that we defined earlier and change them on the fly. Move our elements we playing with earlier out of the way. So I'm going to go ahead and save this real quick and do File, Save Document. So it's good to back up your work and keep going. You never know when you're going to plug in something and destroy your processor's ability to think and crash your whole computer. That's when you're having fun. Right when that view happens. So what we're going to do to try to make ribs out of this, is just one way to make ribs without using an orthogonal XY, is we're going to go ahead and take this surface and do an offset. So if we take this surface and we go back to our surfaces, and that is one of the elements we can affect is offset. And there's direction is one of them. One of the variables. And if you just put in a number, you should get a solution for some reason. Anyway, well, that ends that, and I'll get back to the offset in just a minute on the third episode. Thanks for watching.